Hi, my name is Cindy, and today we're going to design a carnival game. We're going to use probability and expected value to help us do that, and we'll learn more about those topics when we look at the gizmo in a minute. But first, we need to pick our game. There's lots of ideas on the internet, so you can just do some research, see what you'd like to do the best. I'm also going to go over a few ideas with you today and show you the materials you're going to need to play those games. Our first game is select a cup game. You just need a styrofoam cup or a paper cup. And on the bottom of the cup, you're going to write a number. You'll write 0, 1, or 2. We're going to use two different sizes of prizes, actual prizes for our games, either a small or a big prize. And then some cups will also be no prize. So 0 would be no prize, 1 would be a small, and 2 would be a big prize. Put those cups on a flat surface. The players would then select a cup, and that would tell them what prize they win. Also, you could use a spinner using different prizes for different sections, balloons where you put different prizes inside, written on a piece of paper inside the balloons. And you also could do a duck pond type of game, and we'll look at that when we look at the gizmo here in a minute. Then you need to select prizes. You could select a small and a big prize. Like I said, you're going to need several of each. And you could do candies. You could do different sized candy bars, granola bars, brownies, cookies, fruit, different kinds of fruits, different sizes of fruit cups, yogurt, lots of different ideas. Those are all food ideas, but other ideas would be if your student, for example, is an artist or artistically inclined, you could have them draw small and large sketches to use as prizes. So just get real creative. Just think about what you have around the house and what your students' interests are. Then you're going to have to figure out how to pay for the game, what you're going to use for paying for the game. You can use play money, which you can print off of the internet. You could also use Monopoly money. You could use chips. You could have plastic chips or just cut some out of cardboard. Use that. You could also use Carnival tickets, which those you can also print off the internet. For each of your prizes, you're going to have to assign a value. So for example, let's say we assign a value of $1 or one chip or one ticket to our small prize, and then we'll, for example, assign a value of $3, 3 chips, or 3 tickets to our big prize. The goal here is to try to charge enough per player so that you either have a fair game, which means that you come out even, you don't lose money, but you don't make money, or you make money. So we will learn more about that when we look at the gizmo. So let's go ahead and go over to the gizmo and see how we can design our game. Okay, we're all signed in. Let's look for our gizmo, which is Lucky Duck. There it is. And then launch the gizmo. This gizmo is a carnival game run by Arnie the Carney, and it involves selecting ducks from a pond. And as you select each duck, you're going to get a prize, either no prize, small prize, or big prize. And there are several games that you can play, games A, B, C, and a bunch of random games. So let's go ahead and play game A and see what happens. We can draw 1, 10, or 100. Draw 100 as those ducks are drawn. The number that are drawn updates in the middle, and also the revenue and the cost updates underneath. Let's take a look at that cost and revenue a little bit closer. This shows you the computation of the game income, the total of the prize giveaway, what it cost Arnie to give the prizes away, and then the average giveaway value, which is the cost it is every time a duck is drawn. So it cost Arnie $2.52 every time a duck is drawn. In theory, he should charge more than that to make money. So in this game, he lost $102. You can also look at a couple graphs that show long run trends, and the two types of data shown, either net gain loss or average giveaway. And we can zoom out because we had 100 draws and drag to see that whole graph for the net gain loss. See how it changed with each draw, and then there's your average giveaway. So he's not charging enough, obviously, for this game. Let's go to design the game. He can change for any of those games, A, B, C, the random games. You can change the cost to play here at the top, and then you can go back to the game and play it with that value. You can also design custom games, which is what we want to do. So we're going to change the number of prizes. Now we have custom added to the menu down here. Also change the value of the prizes, which changes the prizes shown at the top. Let's see what happens. Let's see some data about this to see what probably, theoretically, will happen with this game. Blue bar shows the probability, theoretical probability of getting no prize. That's 9 over 19. The orange bar shows the small prize probability, 6 over 19. And the green shows big prize, 4 over 19. Now, the expected value is what Arnie can expect to pay each time a duck is drawn. Again, this is theory. So you take each probability multiplied by the value, add those all up, you get $2.42. So in theory, you should charge more than $2.42 to make money. So let's just go ahead and make it $2.60. Now let's go to play the game, draw 100, and just see what happens. So as everything counts up, the totals change, and the cost was greater than the revenue, and he lost money on this. So yeah, he didn't charge enough. So that's going to happen sometimes. It's not always going to happen, but let's go ahead and just clear and draw again and see what happens. Of course, he can always increase the cost to play, and then that would increase his revenue. Okay, this time he made money. So you can see that this is all theory. Don't know what's going to happen for sure. You just have to use your theoretical numbers and do the best you can. And I hope this will help your kids design their carnival game, and I hope they'll have fun playing it.